So did you know that smell of fresh cut grass that everyone likes?
I know.
So did you know that actually that smell of fresh cut grass is actually a pheromone that the grass is releasing as it's getting cut to tell the rest of the grass around it, help, I'm in trouble. So actually that really nice fresh smell you're getting is kind of like grass is screaming. Now for anybody that's like, well, why does that help the grass? I have no idea. I always have this idea of the rest of the grass going like, oh, thanks, man. I don't think it actually does that, but yeah, so now you know. Okay, so as far as today's lesson is concerned, today we're going to talk about crop management. And in particular, we're going to compare and contrast the practices of permaculture in comparison to large-scale industrial agriculture. And in particular, we're going to take a look at what happens and some of the issues that can arise when some of those small-scale subsistence farmers try to make that transition to large-scale intensive agriculture. So to go ahead and start, we're going to look at permaculture in terms of crop management. So as far as permaculture is concerned in crop management is really about soil management. Everything we're trying to do is about building healthy soil. So as far as looking at healthy soil, what does good soil look like? What are some of the characteristics? Who can tell me? Who's got any ideas? If I'm holding a handful of really good soil, what does it look like?
Moist.
Yeah, so it's moist, so it's kind of spongy. It holds water really well. Good. So it's kind of moist. I know some people love that word. It's moist. Yeah. Good. What else?
It varies in color a little bit.
Yeah, so actually really good soil is kind of like a coffee color. It's kind of like coffee color to almost like a black color. So that also tells that it's really good soil. Good. So it's spongy. It's kind of coffee colored. What else? Yeah, good. So as far as soil structure is concerned, good soil is kind of crumbly, actually. So the reason for that in particular, without getting too much into details about the science of it, the little microbes like bacteria and fungus, they secrete these polysaccharides, which are like these sticky carbohydrates, and it actually binds soil together. So that allows it to be porous, which allows for better aeration. But because it's sticky, it actually holds nutrients really well. So yeah, good soil is kind of crumbly in soil structure. Good, so it's crumbly, it's coffee colored, it's moist. What else? Has anybody ever smelled it? Good soil smells really good. It smells like kind of earthy almost. In fact, did you know, if you breathe in good soil, it actually releases endorphins in your brain. Go home and bump a line of that. Cool. So it smells good as well. There's one characteristic that we're still missing. What else does really good soil have in it? When I hold a handful of that spongy, coffee-colored, crumbly, good-smelling soil, what else is in there? Bugs. Good soil is teeming with life. In fact, in good soil, there's more life in a tablespoon of good soil than there are people on the planet. And all this life and all of its different manifestations, the bacteria, the fungus, the protozoa, the nematodes, the microarthropods, the worms, all of these little manifestations of life are what we call microorganisms, for the most part, and they represent what's called a soil food web. And ultimately what's happening in that soil is all these manifestations of life in all their different forms and sizes and makeups, they're essentially in there eating each other, recycling the nutrients, and that's what feeds the plant. So as far as the two roles of the soil food web, all those little microorganisms, there are two main roles of that soil food web, is to build soil structure and to recycle nutrients to help feed the plants. So when I say build soil structure, again, it's about all those little critters in there that are turning the soil over, they're sticking it together, they're creating soil structure, which allows for water retention and better aeration, so the soil is more oxygenated. So as far as permaculturalists are concerned then, our real goal is to build healthy soil. The way we do that, we're trying to empower our little microbial friends to do all of the work for us. As far as empowering microbes is concerned, the best things we can do to build good soil and empower microbes is give them food and give them habitat. The easiest ways to give them food and habitat, add organic matter. So to go ahead and start, we're going to go over some very basic techniques as far as how you can add organic matter and increase the microbial profile that exists within your soil. So, to go ahead and start, who remembers anything that I might have mentioned today about different ways that we're trying to remediate our soil? So, who the fist the big pile? Remediate means to make better. Yeah. So, so remember when Aubrey had to fist that big pile? What was that? Huh? Compost, good. So a very basic way, a big pile of shit, yeah. A very easy way to build soil. Compost. Take those raw organic materials, put them in a pile, cover them with plastic, add some water. You're creating soil through that process. That's composting. Good. What else?
Add some sugar.
Add some sugar in there, of course. Yeah, so we'll put that in terms of biofertilizers. Yep. Definitely. Put some sugar in there. Yeah, give me some sugar. Good. So biofertilizers, I'm also going to say EM. Again, EM stands for effective microorganisms. We're going to have a whole lesson on fermentation. But for the sake of this, biofertilizers and EM is essentially the same kind of idea. It's taking raw organic materials, putting them with a liquid culture, so usually sugar and water. And through that process, you basically allow them to recycle the materials, they unlock the nutrients, they propagate themselves, and that also adds a lot to building good, healthy soil through biofertilizers and EM. So we got compost, biofertilizers. Who remembers the one thing I was showing you with the apparatus? With the fire? Biochar, yeah. Biochar, or apparatus, I guess is just like a fancy way to say like a pipe. Yeah, so biochar is another really good one. Good. So again, biochar is another thing that is very good at remediating soil. So it helps with nutrient leaching, it's great for water retention, it acts as a carbon sink, it's great habitat for microorganisms. All that surface area, it's like a hotel for bacteria. They love that stuff. So, good. Who can think of anything else?
Your piss?
My pee, yeah. We'll consider that biofertilizers. Yeah.
Those magic trees you were talking about from India?
Yeah, the moringas. So we'll say plant dynamics is a big one. So you have certain trees, all kinds of nitrogen-fixing trees that actually aid in soil fertility. So as they're growing their roots out, they're basically breaking up the subsoil. They're allowing aeration through that subsoil that encourages microbial growth. The more microbes you have, the more they break up the soil and create soil structure. Yeah, so in plant dynamics, good nitrogen-fixing trees, stuff like that is definitely a good one. Yeah.
This may or may not fall under the plant dynamics, but segregating them so you don't have a bunch of the same type of plant together.
Yeah, so we'll essentially say, so a good thing about that is that when you have a lot of the same types of trees in the same area, they're essentially mining the exact same nutrients. So it actually is good to diversify your plant dynamics as far as how you spread them out. Yeah. One more I wanted to touch on is, well, two more. So what do we do? This is something we do in the developed world a lot more as far as, so when I'm not growing corn, what might I grow? Yeah. So what do we usually grow? It starts with a soy and ends with a bean. Soybeans, yeah. The reason we do that is they're also nitrogen fixer. They build soil fertility. We call that crop rotating. So crop rotations is a very good one. Out here, a lot of times they rotate rice with cabbage, which is kind of interesting. And one more I'm going to put up there that I also mentioned today, worm castings. So if there's one thing I've learned through my experience with permaculture, there's something seriously incredible about poop. You can literally do anything with it, and it's very, very useful. As I talked about with worm castings, when that raw material passes through their gizzard and their gut, it comes out on the other side with far more surface area that allows far more microbes, and it's a lot more nutritious. So worm castings are really good. Good. So these are all different techniques as far as different ways you can work to build healthy soil through adding organic matter. Now, as far as the benefits that you're going to see from doing it with this kind of practice is, first of all, your plants are going to be more disease resistant. Here's the reason for which that happens. So the thing with bacteria and fungus is everywhere. They're all around us. I don't care how much you try to sterilize. They're everywhere. You cannot get rid of them. But we have this idea in our heads that bacteria are bad. What we're actually talking about, more conventionally speaking, is pathogens. They're the bad bacteria, right? And what happens is that when you have a very diverse, balanced microbial system within your soil, they outcompete the bad guys for the food, and they starve those bad guys out. So to kind of give you an analogy, I want you to think about having a big party, and there's this table in the middle, and it's got 10 big plates of chicken on it. And in that party, there's 500 good guys and about 50 bad guys. I say go, and everyone has to run to the table to eat. Who do you think most of the people at that table are going to be? They're going to be the good guys, and they starve out the bad guys. So it's not that they eat the bad guys, but they outcompete them, and that allows your plants to be more disease resistant. So another thing that goes right along with that is a balanced nutritional profile. So what I mean by that is that in conventional agriculture, we essentially feed plants NPK and also sulfur. So the thing with that is that plants are, again, they're just like humans. If I have all of my macronutrients, but I'm not getting any real sources of zinc or boron or copper or iron, all those little trace minerals that I need, I'm more prone to getting sick, am I not? It is the exact same thing with plants. They need all of those little trace minerals and all those secondary nutrients and all that kind of stuff. They can take up to over 60 different trace elements. They really only need about 16 to really function properly. But the point I'm making is that in soil, there's all kinds of different trace minerals and all kinds of different nutrients within that soil, instead of feeding them through artificial fertilizers. So soil provides them with a very balanced nutritional profile that makes them grow a lot stronger, a lot quicker. So another thing that we kind of touched on is, and this has been proven time and time again with organic plants, they are far more drought resistant. A big reason for that, again, the best place to store water is in the soil. So I'll give you an example. You can take 3/4 of a gallon of really good soil. You can take a gallon of water and pour it on that 3/4 of a gallon, and you will not lose any of that water. Good soil is very, very good at retaining water. And because of that, your plants are far more drought resistant. They have more access to water. So beyond that, another little thing I wanted to mention is that you're going to see less weeds over time, and here's why. As I mentioned earlier, this concept we have of weeds is a made-up term. Weeds are basically anything that we don't want. In reality, though, the majority of weeds that we think of are serving an ecological function. They're pioneer plants. They go to disturb soil that's really poor in quality, and they germinate very quickly, and they send down this deep dynamic taproot. They mine nutrients from way down underneath. They bring it up through their leaves, they grow up, and then they die after like a year or two, and then they help build soil that way. So weeds serve an ecological function, but they will thrive in poor soil. But when you have good soil, your plants are going to start outcompeting them, and eventually the weeds will start dying back as they start losing sun exposure, and they'll stop germinating as much. And over time, you will see less and less weeds. So the fifth, and I would say the far most important benefit of simply adding organic matter, this is far cheaper. So I gave an example earlier today about one of the biofertilizers I've made is essentially a 55-gallon drum. I filled it with water, some sugar, and then all kinds of bullshit. I put coconuts in there, rice husks, manure, cement powder, that's literally like rock dust. You could put I literally put all kinds of different stuff. Any kind of weeds we had on the plot that were really thorny, that don't decompose really well through compost, anything like that, I took all of that organic matter and I dumped it all in that big 55-gallon drum, and I sealed it, and I created an anaerobic environment. And in particular, anaerobic bacteria in general are really gnarly. They can eat through rock. And so what happens in that container is basically, if it's like this, and I filled it up to here, it's mostly anaerobic. That substrate, all those organic materials, are going to kind of represent the bulk matter. They all kind of add in this region. And at the very bottom of that layer, you're going to start getting a lot of anaerobic bacterial growth. And in particular, all that anaerobic bacterial growth is going to start eating that pile from the bottom up. As they're doing so, they're releasing all the nutrients into the liquid culture. And in about 4 months, that entire thing is just nothing but a huge barrel of Miracle-Gro. It's just loaded with nutrients. And guess what? I could go to the store and get a little bottle of Miracle-Gro and spend like $10, or I can make a 55-gallon drum of it that costs me about $200. That's about $6. So the point I want to make is that this, in the long run, is more economically viable and sustainable for the farmers themselves. So the fact that it is cheap is a huge benefit. Now, at this point, I want to switch gears, and we're going to talk about how commercial agriculture looks at crop management. So, to go ahead and start, when they're first growing their plants, and how this all started back in the 1930s with the Harvard-Bosch process, what is the first thing they're spraying on the plants to help them grow? And
Fertilizer.
chemical fertilizers, good. So this all started with chemical fertilizers. They basically, in particular, after World War II, the petroleum industry was booming, but all of a sudden they didn't have any guns or any bombs or anything to make. They had all this ammonium nitrate, and they found out, that's nitrogen. That can actually help plants grow. So they started spraying it on plants. The whole green revolution, that started with chemical fertilizers. And what they did find, without a doubt, it absolutely helps plants grow. They got very big very, very quickly. Here's a couple things that we did not find out until later, though. A couple things about chemical fertilizers. So, first of all, I want you to think about a 6-year-old kid on steroids. It's fucking weird, right? It's weird. A baby plant that is just overloaded in nitrogen fat is essentially the same, in the sense that when that plant is fed a bunch of synthetic nitrogen, it grows very, very quickly in an unnatural way, and in particular, its cell walls are very weak. And in general, that plant is vulnerable. And you know who knows it's vulnerable? Are insects. Insects love nitrogen fat plants. So what ends up happening is that chemical fertilizers add to the possibility of insects attacking your plants. So you fed them chemical fertilizers, they started getting a bunch of insects, and now we have to give them something else. But before I move on to that second step, the other thing that can be problematic about chemical fertilizers when you're not applying them in the right amount is that if you put too much of that on it, then the majority of it is not going to get absorbed by that plant. It's going to leach through the ground, it's going to go to the groundwater, and essentially it's going to pollute groundwater. So I'll draw a little picture for you here. This is the United States. Yeah. This is the Mississippi River. I live right about. Yeah. So in particular, the interesting thing is that, as we all probably know, the majority of the food that we eat is produced in places where I come from. It's all in the Midwest. The Corn Belt, the Wheat Belt, all this kind of stuff. Interesting thing about that is that the majority of these fields, they're sprayed with chemical fertilizers. Sometimes they might put a little bit too much. This was definitely more of an issue about 10 to 20 years ago than it is now. We've gotten better at it. But what they found was that all of those fertilizers, all those nitrates that they were putting in the soil, were leaching through the ground. They were collecting in the groundwater. That water was basically running towards the Mississippi River. It drains into the Mississippi River. It runs down until the Gulf of Mexico. And now there's an area that they say is the size of New Jersey that is a nitrogen dead zone off the Gulf of Mexico. What that means is that all the nitrates that have collected in this area, they cause aqua blooms and algae blooms. They cause algae blooms, and those suck all the oxygen out of the water, and fish can't live there. So a nitrogen dead zone is a place where it ends up that fish aren't able to live or anything. And that happens periodically throughout the year, and it's a very large problem in areas like this. Another really interesting thing that I just learned, you know this little area here? It's right near the Gulf of Louisiana. It's by, I think that's like where Baton Rouge is. Do you know that that is called Cancer Alley? It has the highest cancer rates in the entire world. Right here? Yeah. So, what I'm getting at is that chemical fertilizers can help plants grow very well, but they had unforeseen consequences that we're now having to deal with. So they've polluted groundwater, which is definitely an issue, and then they've added to more insect attacks. So now, I've sprayed chemical fertilizers, my plants are growing very well, but they're starting to get chewed up a lot by insects. So now, what do I do? Yeah, so in particular, we use insecticide at this point. So with insecticide, here's where it starts getting really interesting. Is I'm now spraying insecticides on my plants, and of course they kill the bad guys, but guess who else they kill? All of those beneficial microorganisms in your soil that make up your soil food web. So when you start spraying insecticides, you begin to compromise your soil food web. As your soil food web starts running out of balance, it basically creates a system where it's an environment that's more conducive to the bad guys being able to thrive. And in particular, when you start compromising your soil food web, you start getting more disease. In particular, you start getting more parasitic fungus. So, now I've started spraying insecticides to get rid of all the insects. I start seeing more parasitic fungus. Now what do I spray on the plants? Give you a hint. They all end in "-icide, and they just start with the fungicide. Thank you. So now I have to spray fungicide. And at this point, when you start spraying fungicide on your plants, you've completely compromised your soil food web. All the beneficial fungus that's in that soil food web, all the mycorrhizal fungus, all the saprophytic fungus, all that stuff that you need in that soil to decompose organic material and recycle the nutrients, is now being killed off by this fungicide. So at this point, now that I've killed off the fungus in my soil, I've created what's considered a bacterially dominated soil. So it has lots and lots of bacteria in it. Guess what loves to grow in bacterially dominated soil? Weeds. Weeds love bacterially dominated soil. So at this point, I started with chemical fertilizers. They help my plants grow. They cause a lot of insect attacks. I sprayed insecticide to get rid of the insects. They cause a lot of parasitic fungus. I sprayed fungicide to get rid of the fungus. And now I'm seeing lots and lots of weeds. So now what do I spray? Herbicide. Yeah. So now I'm spraying herbicide to try to get rid of all these weeds that I've actually helped to create. Excuse me. So at this point, now I have to spray all this herbicide to get rid of the weeds, but I do not want to kill my crops. So what is the last step in this cycle? It's got to be Roundup ready. GMO seeds. Now, I want to be very clear here. I am not here to shit on GMO seeds, okay? They feed a lot of poor people. The point I'm trying to make is that you have to pay for them. Every step along the way now, you have to pay for that. You have to pay for that, you have to pay for that, you have to pay for that, and you have to pay for that. And you've created a huge cycle of financial dependency. So in particular, what we found is that over the last 2 years, we've been trying to get to know this place a lot better. We've been doing a lot of interviews, talking to farmers, trying to really understand what is it like to be you? Like what do you grow? What challenges do you face? What's your favorite part? All that kind of stuff. And without a doubt, the feedback that we've gotten has consistently told us that the two main things that cut into their profits every single year are chemical fertilizers and pesticides. And they're starting to say that they're getting more sick. So, the point I want to make here is that what you get with commercialized agricultural practices, especially when developing countries try to make that transition, is you create a lot of financial dependency and it disempowers farmers. And you get these cycles of debt that are very problematic. So, who's heard anything about what's going on in the Punjab region of India? It is amazing to me sometimes how many things we know about and other things we have no idea about. So I found out this information by reading this book. It's called Uncensored. It's a private investigative journalism firm that every year they find the top 25 most underreported important stories in our entire world and they write a book about it. So one of the top stories of 2014 was this one. So in particular, in the Punjab region of India, they are responsible for producing most of the cotton that we use. It's a very good climate for it. All this cotton that I'm wearing, all the cotton that we all wear, most of that is produced in the Punjab region of India. And what they found is that about 20 years ago, they had a company that came in and they said, hey, we want to help all you Indian farmers with your crop yields. So we're going to give you these chemical fertilizers and they're going to help your yields, we promise. And so the Indian farmers are like, okay, we'll give it a shot. And the first 3 to 5 years, they saw huge increases in their crop yields, and they were very, very happy. What they found in 3 to 5 years is that as their crop yields started to go up, so did the amount of insect infestations that they were getting. So the company said, don't worry, we've got something for that. We've got some insecticide. So then, before you knew it, 20 years has gone by, and at this point, their yields have actually dropped to half of what they were before they started. And the GMO seeds that they're now having to buy, this BT cotton, started at 70 rupees per kilogram. It's now 700 rupees per kilogram. And this has created a huge cycle of debt in the Punjab region of India for many of the farmers out there. So, over the last 20 years in the Punjab region of India, over 300,000 farmers have killed themselves because of this. If anybody's grown up around farmers, farming is not a job. It is a way of life. And when you take away a farmer's land, you take away his life. And the point I want to make is that sustainable agriculture is not just about an environmental issue. It is an economic issue. It's not just about what's happening to nature. It is about what's happening to farmers. Do you have any questions? Yeah.
So if they start the chemical fertilizer and then they realize it's really good, and then they realize there's all these problems with it, there's no way to just like stop it and kind of
Good question. So
restart,
that relates to a question I feel like I get a lot about, like, well, so first of all, how do we deal with the issue and how do we kind of make the transition? It's hard. Like, I want you to think about, so, you know, where I'm from, we have corn farmers that literally farm thousands of acres at a time. I want you to think about being that corn farmer that looks out on his thousands of acres and says, all right, I've invested all of my money in this heavy capital, this heavy machinery. I've invested all of my resources, all of my seeds, everything is in corn and doing it this way. How the hell is he going to make that transition? You know, that's a hard one. And I think part of it is that the problems like these have gotten to the extent they have because we don't really know about it, do we? Most of the things that are actually really affecting our world, we don't actually know about, which I've barely even reached the surface of. We got 4 more lessons left. But I think that as far as, I think a better question is what can I actually do, right? So the first step in solving a problem is realizing that there is one. So what can you do? I would say, and here's the thing, I recognize your privilege in being able to get organic food or localized food, but if you can afford and you can vote with your dollar to say, I want local organic food, you represent a market, and that market is growing. And if that market grows enough, the suppliers will listen to that. So, I mean, that is a step you can take. As far as the large-scale transition of getting away from this and more towards something like this, that's going to take a shift in consciousness of the masses. And that's, but it starts small. You know, everything has always started very, very small. And I think that that's, never underestimate that you matter and that your choices do matter. So, yeah, it's a big transition. But, yeah.
Could monoculture be the problem though? Because I had actually did a research project on monoculture, and I realized that there's just no diversity, and that affects the soil itself. So could that be the problem?
It's a huge problem. Yeah, so the fact that it's a monocultured field leads to all kinds of problems. So in fact, that adds to insect infestation, because it's just like I kind of said earlier with integrated pest management with trees, is that if I'm an insect and I start eating at the corn, and then sweet, I've got 40,000 acres of it, that insect infestation is going to get way out of control very, very quickly because there's no diversification. Like and part of it too, again, kind of relaying off of that, is with a monoculture field, you've destroyed all the natural habitat for all of the natural predators that actually eat that insect, eat that pest. So that's what happens a lot. Aphids is a big problem, especially with vegetables and shit. Their natural predator is a ladybug. And the problem is that when you spray pesticides, yeah, you got rid of all the aphids, but you also got rid of all the ladybugs. And those aphids reproduce way faster than the ladybug does. So before you know it, that aphid population has gotten way out of control, and the ladybug can't even keep up. And then you try to spray it again to get rid of it, and you just kill any ladybugs you might have there. So, yeah, it's part of it too is patience. You know, they always say that with organic system, the first couple of years are kind of tough because you're gonna have pests and whatnot. But if you let nature take its course, like, do you see any aphid infestations or spider mites or anything like that out in the middle of the forest? Nature has a balance; it always has. And the idea is that we want to try to re-instill that balance. And so, but that takes patience. You know, agriculture doesn't exist in nature, so it's a compromise. Yeah. Any other questions? All right, gang. Yeah, question.
What was it that you were talking about when we were on site, where the banana trees were at the way back, and you had the water so it would go downward?
Contours, yeah. So contour garden beds. On Tuesday, we're going to have a whole lesson on water. It's a fun one. But contour, the idea of putting garden beds on contour is just about understanding that water wants to follow the path of least resistance, right? So if you have a garden bed like this, it's going to want to run off that really quickly, and it's also going to cause more soil erosion. But if you level that out, that water is going to spread out very, very slowly and evenly, and as it spreads out slowly, that it gives it that chance to actually sink into the ground. So, yeah, contour garden beds, we're going to talk more about that. Any other questions? And to be clear, just because I am the last person that's ever going to try to like be arrogant and shit on a corn farm or anything. I grew up in those areas, and I completely understand why they do things the way they do. And I don't blame farmers whatsoever for the manner in which they do farming. But it's a much bigger issue that I do think we should all try to recognize and address at some point. Hopefully, like right now, we should start doing that. Okay. Any other questions? Okay. Are you ready?